Okay, these are some exercises from 3.8. A couple of these we did in class and a couple of them you have for homework. So I'm going to go through the solutions for all of them. So just skip to the one that you have a question on. So this one is number 2. So we're going to do number 2 first. It says Rosita wants to install a circular sink in her new triangular countertop, and she wants to choose the largest sink that's going to fit. Which point of concurrency must she locate? Okay, so we're going to draw a diagram. So here's her triangular countertop. And she wants to find the biggest sink that's going to fit. So with this countertop, this is probably about the biggest sink that she can fit in there. All right, what do we notice about the center of this circle? Here's her circular sink. The center is probably about here. Might be a little bit off, but okay, so that looks like it's about the center. What point of concurrency is that? Well, this point, we can see that if we look at the distance between each of the sides, this point here should be the same distance from all of these sides. And again, we measure distance perpendicular. So our goal for installing our sink is to find the point of concurrency that's equidistant from all the sides, and that is called the in-center. All right, the next one, number 3. Oops. It says that Julianne Shive wishes to center a butcher block table at the location that's equidistant from the refrigerator, stove, and sink. Which point of concurrency does she need to locate? All right, so again, I would draw a diagram. So here's my refrigerator, here's my stove, and here's my sink. And I'll label these. Refrigerator, stove, and sink. Which point of concurrency does Julianne need to locate? Well, we want it to be equidistant from all these points, right? So these points form a triangle. And what point is going to be the same distance from the refrigerator as it is from the sink, as it is from the stove? And it'll probably be more like this. So what is that point that's equidistant from all 3 of those? Here's where we want to put the butcher block. Well, if you look back at your conjectures, the circumcenter conjecture says that the circumcenter is equidistant from the vertices. Well, those are our vertices, so that's what we're looking for. We're looking for, in this case, the circumcenter. All right, and then the next one is very similar. We did this one in class as well, and you can read through the problem on your own. And so our goal is to find a table to put the pies on that is the same distance from each of these class tables. So here are our vertices. We want to locate a point that's the same distance from each of them. So it's going to be somewhere around here. Maybe a little bit lower, but it's going to be in between all of them anyway. And again, we're using the circumcenter because we want it to be the equidistant from the vertices. All right, so the next one that you had for homework is number 5, and then you also had to do number 6. So I'm going to go through those solutions now. The first is to draw a large triangle and then to construct a circle inscribed in the triangle. So here's our triangle. The first question we want to ask ourselves is, what point do we need to locate in order to construct the circle for this problem? So if you look back, and I'll flip back in just a second to the beginning of this lesson, it says that we want to construct a circle inscribed in the triangle. Okay, so if a circle is inscribed in the triangle, that means that the circle touches each of the sides of the triangle. So if the circle is going to touch each of the sides of the triangle, then we need to find a point that is equidistant from those sides. So what point is equidistant from our sides? That's the in-center of the triangle. So we need to construct the in-center of the triangle. So I'll just write that up here. The in-center is equidistant from the sides, so we need to construct the in-center. Okay, so to construct the in-center, we need our compass, and we're going to construct the 3 angle bisectors of the triangle. So here's our compass. Okay, and we're going to take our compass and we're going to put it on one of the vertices. Okay, and to construct the angle bisector, we're going to draw an arc and we're going to find a point that's equidistant from the sides. Okay, so there's one point that's equidistant from the sides. We're going to do it again for the second angle. Bisect this angle. Find a point that's equidistant from the sides. And do it again for the third angle. We're finding a point that's equidistant from the sides. So draw your arc, and then find a point that's equidistant from those sides. Okay, and then these are our angle bisectors. Now we need to actually draw the angle bisector. And we're looking for the point that those 3 angle bisectors meet. So through the vertex, through one of those points, through the vertex, and through this point, and through the vertex, and through this point. Alright, so this is the point of concurrency with all 3 angle bisectors, right here. So this is the in-center. Okay, so now this is the center of our circle. So we're not done. We need to construct a circle that's inscribed in the triangle. So we're not done. We need to now construct a circle. And that's really what your compass is for, is really drawing circles. We use it a lot for drawing arcs too. but this is going to be the center of our circle, and we need to set our compass so that it touches one of the sides. Okay, so once we have the center of our circle, which is the in-center, and then we have, and really it should be the same, the in-center should be the same distance from the sides. So you do want to construct one perpendicular just to figure out how wide your compass should be. Mine's a little glitchy, so it's going to be a little bit off, but yours might be a little bit off too. But the idea is that you can figure out which point of concurrency you want to select, which in this case we reasoned through the in-center. So we wanted to find a point that's equidistant from the sides, and we wanted to find the in-center because the in-center is equidistant from the sides, so then we had to construct the in-center. So see how here it's a little bit off, and yours might be a little bit off too, but we're really just looking for the whole process, that you can do all of that, reason through that. Okay, the next one is to draw a triangle, and we're going to construct a circle that's circumscribed about the triangle. So let's go back to our So here, a circle is circumscribed about a triangle, and so that's what we're trying to do. And so this triangle touches, each vertex of the triangle touches the circle. So we want the radius of the circle to be equidistant, or the center of the circle to be equidistant from the vertices of the triangle. So let's go back to our problem. And first we're going to draw a triangle, like it says. Okay, so here's our triangle. And we want to construct a circle, or a point of concurrency that's equidistant from the vertices. Okay, we have a name for that. The circumcenter is equidistant from the vertices. So we need to construct the circumcenter of this triangle. And the circumcenter of this triangle is going to be the center of the circle. So the circumcenter of the triangle, we're going to find that because it's the point of concurrency between all the perpendicular bisectors. So we need to construct our perpendicular bisectors. So get your compass, and we're going to construct 3 perpendicular bisectors. So when you construct perpendicular bisectors, remember that you need 2 points that are equidistant from the endpoints. So I know a lot of you just draw it above and below. That's perfectly fine. So I'm going to do it that way. Okay, so there's 2 points on my perpendicular bisector of my base. I'm going to do it again for one of my sides. Okay, there's my 2 points for my right side, and I'm going to do it again for my left side. So I'm going to connect all of those perpendicular bisectors. And my circumcenter is the intersection of those 3 points. So there's 1, there's 2, and here's 3. All right, so this is my point of concurrency for all the perpendicular bisectors. So this is my circumcenter of my triangle. So I'm going to use that as the center of my circle. To construct a circle that is circumscribed about the triangle. So here's my circle. This circle, if you look at it, it touches each of the vertices of the triangle exactly 1 time. Okay, this vertex exactly once, this vertex exactly once, and this vertex exactly once. So you're gonna I used a shortcut on here. So actually, let's do it with your compass. So your compass, you're gonna put on, and we'll use the thicker line. We'll do it in orange. You're gonna put it on the center, your circumcenter, right here. And you're going to make it as wide as it is to one of the vertices. And then use your compass to draw the circle. So this is a circle that is circumscribed about the triangle. And we needed to do that. Before we did that, we needed to find the circumcenter of the triangle. Okay, so that's your homework for tonight. So please jot down any questions you have, and we can go over those next time I see you. Thanks.